Assalamualaikum and hello. My name is Rabiato Adawiyah binti Ebaka. Today I would like to present my final year project, detection of white spot syndrome virus WSSV in mackerel scarlet species from Setu wetland. The growing demand for mackerel in Asia, Europe and America has stimulated an increase in the production of mackerel. The total production of mackerel from aquaculture in Asia and Africa was over 138,000 tons, and the production of mackerel in Malaysia reached 60.84 tons. For blood statement, white spot syndrome virus can cause up to 100% mortality for shrimp industry. White spot syndrome virus also infect a wide range of aquatic crustaceans of all life stages in marine, brackish, freshwater, including crab, crayfish, and shrimp. Mackerel have been considered to be a particularly dangerous threat to shrimp farm because they are generally believed, based on a report for the species Kyla serrata, to be highly tolerant to the WSSV and remain affected for long period of time without signs of disease. Significance of study to determine the presence or absence of white spot syndrome virus in Scala species, to establish strategy to control and prevent the transmission of pathogen from spreading, and help the prevention method that may be used to prevent infection at the location. Objective for my final year project is to detect the presence or absence of white spot syndrome virus in wild skylar species in Setu wetland. This is taxonomy for skylar species. White spot syndrome virus is only member of the family Nemaridae and genus Wispovirus. The genome of different WSSV isolate range from 292 kbp to 307 kbp in size. Clinical sign for WSSV is anorexia, lactasia, and white spot in the cuticle. White spot syndrome virus in wild crab. WSSV target originate from embryonic mesoderm and ectoderm. Also produce hypertrophic nuclei with intranuclear inclusion body method. 50 sample of mackerel scarlet species we take from Setu wetland Terengganu, and we measured the weight and carapace diameter, and we also observe any external and internal clinical symptoms. For this experiment, we use gill, heart, stomach, and hepatopancreas. 5 samples we pull in one centrifuge tube. DNA extraction. I use GF1 viral nucleic acid extraction kit procedure. For the PCR analysis was carried out according to the method by law and as described in OIE 2050. For the result, 24 males and 26 females mackerel were identified. The average body weight and carapace length were 105.1 grams and 8.23 centimeters respectively. Primary PCR jet electrophoresis result. This is my nested PCR jet electrophoresis from the experiment. 50 sample mackerel scarlet species we collect from Setu wetland, Terengganu. For the PCR result, all of the collected sample of scarlet species were found to be negative result using primary and nested PCR analysis. For clinical signs, no clinical signs were observed on the sample. For Otolasmis species, 10 mackerel were detected with the presence of Otolasmis species on their gill. For the previous study, practitioners have been found to be positive for WSSV infection despite their absence of clinical signs. Most of the crustaceans, including decapod, are known to be carriers of WSSV, and no white spot syndrome virus and no white spot have been observed on them. For the PCR result, similar results were reported by EZ 1004 on Skyla serrata taken from Australia water. However, our finding contrasted. Several papers show positive result for WSSV infection in mackerel using nested PCR. This is because the primary PCR analysis usually use less specific sequence to amplify DNA sequence, while the nested PCR analysis use a more specific sequence to amplify DNA from the previous product. WSSV was detected in culture Skyla serrata in Taiwan using nested PCR. Plasmid species were found to occur in largest number on the gill of mackerel from all over the Asian country, include Thailand, Singapore, Indonesia, and India. a total of 50 samples of mud crabs, Scylla olivacea, Scylla paramamosai, Scylla trachubarica, that we collected from certain wetlands have been identified for the presence or absence of WSSV using primary and secondary PCR. In this study, all the samples show negative results for the presence of WSSV. In conclusion, WSSV were observed in our sample. For the future study, it should be carried out and number of the samples should be increased in order to get more accurate representation of wild mud crab population. In addition, the sample should be sent for sequence analysis to confirm the virus WSSV. This is important since WSSV infection can treat all stream culture and other crustaceans in Malaysia. This is my grand chart. This is my reference. Thank you.